Hi everyone, welcome back. In this video, we're going to continue where we left off last video. Last video, we introduced pandas, and more specifically, we started working with the two primary data storage objects in pandas, series for one-dimensional data and data frames for two or n-dimensional data. So for series, we had this sequence of populations for cities in Washington state, and we also had nice string-based labels for each one of these populations to identify which city they belong to. We saw how we could create a series with this data using these nice city strings as a label-based index. We saw how we could do indexing based on label or by position with iloc. And then we saw some built-in functionality like the ability to simply call a method to compute a summary statistic like the mean or standard deviation. Then we moved on to data frames and saw that our series knowledge helps us understand data frames because we can think about, say, each column in a data frame like a series or each row in a data frame like a series. So here's where we built a data frame based on some two-dimensional city data in addition to, say, a population column like we had with series. We also added a size column. Is this a small, medium, or large size class? Once again, we use the city names as the nice label-based index for the data frame like we did with the series. We were just working with the population values. Then we saw how we could do indexing, grabbing a column directly, grabbing a row directly, both of these cases using label-based indexing, or using iloc like we did with series to do position or location-based indexing. Now I want to continue here on line 74, and we're going to start working with files. This is typically how you're going to use pandas, right? You have some data, it's stored in a file, maybe like a CSV file, an Excel file, a JSON file, etc. And you want to load it up into a pandas series or data frame, do some interesting things with it, and then possibly write back out the results of the interesting things to file. So let's get started. We already have our population data in a data frame based on the code we wrote last video. So let's make a file that contains some different data, but has a column in common, which will be the city. So let's call this file regions.csv. And regions.csv is simply going to have two columns in it, city and region. With a CSV file, each line represents a row in a table, and values within a row are separated by commas. And these values, separated by commas, if you look vertically down, form our columns in the table. So the first line is going to be our header row, the name of the two columns, city, region. Let's have a few overlapping city names from our population data so that later when we do some interesting things like perhaps join our population data with our regions data, there'll be some cities in common that we can join on. So let's say Seattle is in the western region of Washington. Let's say Spokane is in the eastern region. I think we also had Bellingham in there. That would be the west side. And then let's add a city in the middle of Washington state. Let's do Moses Lake, and I'll put this in the central region. So don't forget to save your file. So I just saved regions.csv, and now we're going to go back to main.py, and we're going to open this file, load it into a data frame, and we'll print it out. So I'll do regions df is going to be assigned pd dot, and the pandas function that we want here is read CSV. So with read CSV, we simply pass the name of the file or the path to the file that we want to open. So this will be regions.csv relative because I purposely put regions.csv in the same directory as this main.py file. If you want to check out the documentation for read CSV, you can see it here. You can also see on the left side of this documentation page all the other read functions that Pandas has. For example, here's read Excel for reading, say, XLSX files. Here's read JSON. Perhaps you have some data stored in JSON format. Perhaps it came from an API, etc. Okay, you can take a look at all of the different types of files that Pandas can open. So let's run this and print out regions df. Nice. It looks like we were successfully able to open and load the contents of our simple regions.csv file into a data frame. Now, note here that because we didn't specify an index, we're getting the default position-based indexing 0, 1, 2, 3. Let's say I want city to be the index, and this is column 0, right? It's the first column in our input file. So I could specify index column 0 to tell read CSV that it should use the first column as the index. Now I have this nice label-based index, and I know that our data frame now only has one column, so we could just store this using a series, but it's okay to leave it as is. Imagine if we had more columns in regions.csv, this code would work in that case as well. Cool. So now we have two data frames, popdf and regiondf, and they actually have city in common, right? They have a common index. So let's see some interesting things we can do with these two data frames. Let's start by joining on this common index. So hopefully you're familiar with this idea of database joins. If not, feel free to head over to Google or YouTube and watch a brief video on database joins. Essentially, as long as we have at least one column or attribute in common, then we can join these two tables on that column or attribute in common and produce a third table. And there's a few different types of joins you can do. For example, an inner join would only include rows in the third table that have matches on this column in common from the first two tables. An outer join would include all of the rows, regardless of whether they had a value match in this column in common. And I'll also mention that it doesn't have to be just like one column in common. Usually it is though. It's like a primary key, foreign key pair, where each key is just represented by one column. But you could have multiple columns in a compound key, and then they'd have to match both values in the column. But we won't get that tricky here. We'll keep it simple. So let's do what's called a pandas merge to join these two data frames together. So I'm going to name the resulting data frame merge df, and I'll call popdf.merge region df. And note that the order here doesn't really matter. The columns in popdf will come before the columns in regions df after the merge, because I called merge on popdf. So it's just what column order you want them to be in. Then we specify which columns to do the merge on. And this can be a list because, like I said earlier, it doesn't have to be just one column. So we'll say on city, and city is our index in both data frames, which is fine because it's labeled. So merge is going to be able to identify the city column is actually the index. So let's print this out and see how it looks. Cool, look at that. So notice that we're missing a few cities. For example, from what's called the right table, the regions df, we don't have Moses Lake in here. That's because there was no city that Moses Lake would match on in popdf. This is also true going the opposite direction, right? So there was Pullman in our popdf. Right here. And since there was no Pullman to match on in region df, then Pullman was not included. So that means that by default, this pandas merge is doing what's called an inner join. And if we go look at the pandas merge documentation, we see that is in fact the case. But we can specify a different type of join by simply overriding this how default value. So let's try doing an outer join. And then we should see Pullman and Moses Lake show up in there. Perfect. Here's Moses Lake. You can see that it doesn't have a population value, so it's represented as NaN, same for size. Here's Pullman. You can see it doesn't have a region value, so NaN to denote missing value. Cool. So there's one interesting thing that we can already start doing with Pandas. We can join data from different tables, different files, different sources together to make a more richer data set and store that all in a Pandas DataFrame. So now let's write the merge DataFrame to a file. This is really easy to do. We're simply going to call to.csv or to underscore whatever file type we'd like to write this out to. And then we'll pass in the name of the file or the path to the file. So I'm just going to call this merge.csv. That's it. That's all it took to get our data frame contents out to file. So here's our to.csv documentation. If you'd like to take a look, I often sometimes will use NA rep to determine how missing values should be indicated, float format, for the floating point precision, how that should be written out. So there's a lot of really helpful keyword arguments with to.csv and essentially all Pandas functions and methods that you can read the documentation to see how they work. So the last thing that we're going to do in this video is one more interesting thing, which is we're going to see data aggregation in action. So data aggregation is this process of gathering and presenting data in a summarized form. And a common approach to data aggregation is what's called split, apply, combine, where you split your data set into subtables, and then you apply some operation to each subtable, and then you combine the results of that operation back together into one table. So the first step, split, is typically implemented using a group by operation. If you have some SQL or SQL background, you're familiar with group bys. If not, we're going to see group by in action, and I'll explain it as we go through. So first, let's start with a picture. Here is a screenshot of a merge data frame table. It doesn't exactly match the data that we were just working with, but it's pretty close. We've got Spokane, Seattle, Bellevue, and Issaquah, and Moses Lake. So let's say we want to split this data set, this table, by size. So we look at the size column and we see how many unique values are there. Large, medium, small, and there's also NaN, missing value. Let's choose to ignore missing values for now. So there are 3 unique values in the size column. So when we split on size, that means that we're going to be creating 3 subtables, one for all the rows with size large, one for all the rows with size medium, and one for all the rows with size small. After we split on size, you can see here's the large row table, here's the medium row table, here's the small row table. Now we apply some sort of operation to each one of these subtables. The operation that I'm going to apply is going to be a mean to each subtable's population column. So essentially what we're doing is calculating the average population for large cities, the average population for medium cities, and the average population for small cities. Obviously, this is a really small table, so we're not going to get too interesting of results for this step to apply mean to each subtable's population column, but hopefully you get the gist. So once we get the average population for each size class, we have 3 results, right? Average large pop, average medium pop, average small pop, and then we combine those averages together to produce a final results table, which will have 3 rows because we had 3 subtables, 3 unique values in the size column that we split on, and then the average population for each one of those subtables. So let's go over to Pandas and see how we can do this quite simply. So first, a little bit of notes. Data aggregation. This is gathering and presenting data in a summarized form. We're going to do split, apply, combine. So first step is going to be to split merge df by size. So we're going to be calling merge df dot group by, and we pass in the name of a column to group by. So this is going to be size, and this method is going to produce a group by object, and I'm going to store it in a variable called grouped by size. Now, if I print out group by size, all we're going to see is that group by size refers to a data frame group by object. This data frame group by object is actually quite powerful because it has a really nice API that we can use to grab a single group data frame, like let's get all of the larges, or perhaps iterate over all of the groups, or even just apply, say, column-based indexing across all the groups, and then our aggregation operation, such as, say, a mean. So let's see these in action. So first, let's grab a single group, which is really just a subtable. Like, let's grab all of the larges. So we're going to try and get a data frame that just has the large rows in it. So this is going to be grouped by size dot get group, and let's ask it to give us the large group. Let's see what we get. Isn't that cool? We got a data frame that looks just like merge df, but it's filtered to only have the large size rows. So that's how you can get a single group. Let's say you want to see, well, what are all of the possible group names? So if I were to print out grouped by size dot groups dot keys, this is how I could see all of the possible names of our group data frames. So these are essentially the unique values that were found in the column that we grouped by. So I could get group large, get group medium, or get group small. Okay, great. Now let's iterate over all the groups. I mean, often in advance, you're not going to know how many groups there are, or maybe you do, but there's tons of them, maybe like 100 unique values. Or just as a, kind of state themed example, like let's say we have data for, cities in all the states in the United States. Then if we do a group by state, then we're going to have, at least 50 different groups. We're not going to hard code getting each one of those groups. We need to write code that is very versatile and can work with any number of groups. So let's just iterate over all of the groups, print out their name and their data frame. So for group name, group df in grouped by size, print group name, print group data frame, and let's just print an extra space in between them so we can see the output. So this is cool, right? Here's the large, here's the medium, and here is the small. Very nice. So now we can actually continue with our split, apply, combine, right? We can do step 2 now. Let's apply a mean to each subtable's population. So let's do this in incremental steps. First, we have a data frame here. It has a population column. We know how to grab that column out and get a series. So I'm going to call it group pop ser, because this is the population series for just this group that we're currently iterating over when this runs. So that'll be group df sub population. So far, so good. Now let's calculate the mean. We also know how to do this. We saw it last video. We'll just call mean on that group pop ser. And let's just print it out. Awesome. So the large group is the most interesting because it has more than one row in it. So the average of 764,753 and 229,608 is 497,180.5. Nice. So our last step then is going to be to take these three average populations and put them into one table. And this will actually just be a series for us because our result is essentially one-dimensional, right? It's just population averages, and we can use the name of this, the name of the size class as the index for the series. So let's go ahead and make an empty series. The data type for this series is going to be float because the result of an average is a floating point number. And step 3, combine. So mean pop ser sub group name gets group pop mean. And now outside of this for loop, I'm going to print out mean pop ser. And there it is. There's our resulting series. So this actually was quite a bit of code to do our split, apply, combine. I mean, we didn't have to do our little aside here where we learned how to get a single group or see what all possible group names are. We could remove this, but it's still quite a few lines of code. Thankfully, Pandas has some syntactic sugar that allows us to shorten this all into one line. So let's do this one more time, another much shorter way. You are going to love this. I can produce mean pop ser again by simply going to our grouped by size, grabbing the population column on the data frame group by object. So this is implemented really intelligently, and we'll grab the population column across all of the groups, and then we'll apply a mean to all of those columns. That will result in a series that'll look exactly like the series that we just produced more manually. So here it is. In fact, this series has some more meta information in it that makes it a better series than the one that we produced. For example, the index is named size, and the series itself has a name, which is population. So there's two ways to do a split, apply, combine, and you'll probably start seeing opportunities to do some data aggregation techniques like split, apply, combine with your own data. And now with Pandas, you have all of the skills that you need to get started doing that. So I'd like to thank you for watching this video and know that you have learned a lot. You can load data from a file into a Pandas object. You can do some interesting things like joins with the merge method, data aggregation with the group by method, and writing out your resulting data frame or Pandas series objects to file using toCSV. Take a look at the documentation. You'll see that there are a lot of different data types that Pandas can work with, and group by and merge are really just scratching the surface. Take a look at all that you have available to you with the Pandas library. That's it. Thanks for watching, and stay tuned for more Pandas videos. For example, the next one I plan to make is going to be related to working with date time in Pandas. Thanks, everyone.